Hey guys, so I'm continuing our special functions, graphing our special functions video. We have two more left over. We have number 5 and number 7. So let's go ahead and jump right into this. So you have their number 5, right? So this you've probably seen, you haven't seen this before, so you're looking at this for the first time. But it's not a big deal here because you have a function, you have f of x, and then you have some function with our double bars there, right? So no worries. You can actually, the easiest way to look at this and do this is just treat it like you would any other function, for now anyways. So look at it as f of x equals x plus 1, and then graph that. Now keep in mind that this is a piecewise function, okay? And this is a special type of function, and it's not a linear line necessarily. Okay, so I'm going to start, my starting point here will be my y-intercept. So at 1, at that point. Now, I'm not looking, so when I see these bars, I am actually not looking to make a solid line. I'm just looking to find specific points. And my first specific point was my y-intercept, and my second will be found in my slope, which is 1 over 1, right? So up 1 over 1, that's my second point. And then my third point will be up 1 over 1, up 1 over 1, and up 1 over 1, right? Now, keep in mind that this is a function, and this is an interesting type of function because what will happen is that this function will be true for all integers. So as I look at my first point right here, this function continues, but then it stops, and then I have an open circle, right? And I have to have that open circle because this is a function. That means when I make a vertical line, I must only reach one point, right? And this one is closed, and this one is open, so it still just counts as one point. So keep that in mind as you're working this out. Okay? So the next one, same thing, continues, open, continues, open, continues, and open. And then the same thing here, and that just goes on forever and ever. Okay, and that's essentially how you work those out. In fact, let me just do this one also for you so you can see how that works. We'll do it with green this time. So I'm treating it as a normal function, right, without my bars. So -3, 1, 2, 3. And then my slope is 1 over 1, so 1 over 1. And these are my next points. Okay, and then I'll stop at that point. So then I can draw my line, open circle, draw my line, open circle. And my open circle always goes above my my next point that is above it that's closed, right? All right, so let's go back to our previous problem here. Now, because we still have to look for our domain and we have to look for our range, right? So looking at our domain, this is all x's. So now again, this is not a complete function. This does actually continue on below, right? And because of that, my domain are actually all real numbers. So if I'm ignoring my y-axis and just looking at my x-axis, every single x-axis is covered. In fact, look, even this one here, right? Even though this is open, this one is still covered by that closed one. My next one is open there, but covered here. And in between, all the numbers in between are also covered, right? Because of our solid lines that I'm drawing here in green. See, those solid lines cover everything. So my domain is all real numbers. Now my ranges, that changes a little bit, as you can see, because now I'm ignoring here. Let me draw my y-axis, right? And I'm ignoring everything else except the points on my y-axis. And you'll notice that with the y-axis, it's different because let's see, it'll start here, go, open, starts here, open, starts here, open, starts here, and then open, right? So you'll notice that with my y-axis, not all y terms are actually taken up, right? See, this one's taken up, this one's taken up, this one's taken up. When I have gaps in between each of these terms, okay. So the thing that I need to pay attention to is like what are these lines exactly? What are those numbers? And you'll notice here that it's 0, 1, 2, 3, 4, 5. So as far as the range is concerned, hey, let me clean this up a little bit. As far as my range is concerned, not everything is covered. There is gaps. There is gaps between every number, every whole number, in fact. So it goes from -2, -1, 0, 1, 2, 3, 4, 5, and it goes on and on and on forever. And it also goes on and on and on at this point, negative-wise too. But it's the whole numbers in any case. So it's not all real numbers. All real numbers means that every number is covered, even the in-between small decimals, like, like let's say between 1 and 2, there's an infinite number of numbers like 1.001, 1.00001, 1.00001, and then eventually you can get to 1.00012, 123, point 1 point, and it just goes on and on forever until you actually get to 2, right? So there's an infinite, I guess pretty much an infinite number that would make a solid line from 1 to 2. Okay, so having said that, you'll notice that with my y-axis, there are gaps between those whole numbers. So it's not all real numbers for my range, but it's actually all integers, right? It's all my integers. And remember what an integer is. An integer is all whole number negative numbers, including 0, and all whole number positive numbers, including 0. So those are integers. And all real numbers is it's all whole number positives and negatives, including 0, but also including all the small little tiny decimals that are in between those whole numbers. So there's a difference between integers and real numbers, right? If you recall that from back from Algebra 1. So that's my domain and that's my range. Now let's take a look at my fourth and last function here. And this is what's called a absolute value. Now with this one, absolute value functions, all of these are going to have a specific characteristic. So for example, for these, this is the special characteristic for these here is that you have that dot circle look to it. Yeah, let me erase this to clean it up a little bit so you can see it a little bit clearer. Right? So this is what the piecewise function for that looks like. But then my absolute value graphs, they're all going to look like V's. Okay? They're all going to look like V's. So one of the easiest ways to do this, I would say, is to graph it. Make a table. So we can start from, what is this? 1, 2, 3, 4, 5. Let's say -5. And then let's say, how about -2, 0, and then let's mirror it at 2 and 5. And let's see what we end up getting. Okay? So I'm going to start with -5. So g of x equals 2 and the absolute value of times the absolute value of 5. And what's the absolute value of -5 actually? -5 is 5, so it's 2 times 5, and that's 10. Now let's go ahead and jump to what it would be if I had +5. What's the absolute value of +5? Well, it's 5. So then it's 2 times 10. 2 times 5 is 10. Okay? Okay, let's continue. How about the absolute value of, let me do it in red, -2? Absolute value of -2 is +2, so it's 2 times 2, which is 4. And I think you're getting the idea here. Absolute value of +2 is 2. 2 times 2 is 4. And what's the absolute value of 0? Well, it is 0. 0 times 2 is 0. So now I can graph this, right? Let's see here. So my y's, I'm going to have to make these into intervals of 2. So make this 2, 4, 6, 8, 10. So then my first point is -5, +10. Second is -2, +4. And then 0, 0. And then my second half is going to be mirrored off of that. And you can see here that this is what my absolute value graphs are all going to look like. They're going to be a V in some shape or form, right? So now as I'm looking at my domain, as you can see here, if it's just my x-axis that I'm looking at, all of my x's are covered, all of them. So then again, I am looking at all real numbers. Now if I look at my range, this graph doesn't really start to exist until I get to y equals 0. Everything below 0 on my y-axis, there is no graph. It doesn't exist. So then what I would have to say is that a set of numbers for g of x exists such that, okay, all my y's have to be, let me shrink this a little bit, all of my y's have to be greater than or equal to 0. Because again, because all my g of x's, all my y's below 0, there is no graph. It doesn't exist. It does not begin to exist. I do not start having y values until I get past at 0 and above. Okay? Why don't I work out number 8 too for you? Yeah? Let's do number 8. So again, I'm going to work this out like I do any other function. And this is my y-intercept. So I start off right here, and then I'm going to make a table. Here, let me do this here. I'm going to make a table, x and y's. I'm going to make a table. And I'm going to go ahead and start off at, let's see, this is negative 1, 2, 3, 4, 5. Let's do negative 5, negative 2, 0, 2, and 5, just like I did on the last one. Okay, so absolute value of negative 5 plus 1 is essentially 5 plus 1, which is 6. And then absolute value of negative 2 plus 1 is 2 plus 1, which is 3. And then absolute value of 0 is 0 plus 1 is 1. And then I can pretty much mirror this to my other one, right? So let's graph this. Let's see, how far do we go? We go 1, 2, 3, 4, 5, 6. So let's just, okay, so 6 and negative 5, that'll be up here. Negative 2 and positive 3, 1, 2, 3 is right there. And then so I can just mirror it, right? I can mirror it. So there's my V. There is my V, and I'm going to draw that as an arrow because it continues forever after that point. Okay, so cleaning up my graph. So there's my V. And so the next thing I want to do, I'm going to clean this up too so I can write my domain and range. So my domain, all of my x's are, again, at play here. All of them are at play. This is a function. My ranges, oops, that's not the symbol for range. My range, again, the question I have to ask myself, as I look at my graph, I get a visual of it. I notice that there is nothing here. The function does not exist, and that number here below, let's clean this up. This number right here is, oh, no, I actually wanted that. Yeah, I didn't want this green. So here, this is 1. So my range, my y values don't begin existing until after I reach 1. So f of x is true. Okay, so my set of f of x, okay, let me start over with that. So my set of numbers, my f of x is true such that, okay, such that f of x must be, all my y's must be greater than or equal to 1. So again, what that means is that for my y-axis, again, I am looking at only my y-axis. This function does not begin to exist until until after 1, greater than or equal to 1, and that is my range. And then I close my set. Okay, I would actually write that over here, f of x such that f of x is greater than or equal to 1, close set, and that's that. Okay, all right. I hope that was helpful, guys. Do remember that you do have a quiz over this tomorrow. Good luck in your studying.